Hey guys, Kotax here, and today I have an interesting video for you guys. So, 5 minutes ago, I was looking up at the Monty Hall problem, and it really intrigued me, and really wanted me to make this video, and I'll explain what I'm gonna do. First, let me just explain this Monty Hall problem. So, Monty Hall, I'm pretty sure, had this show where you had three doors. One of them had a car behind. You had to find which door. So I'll show you how it went. Instead of doors, I have cards. So one of these cards is a joker, and I'm going to give you guys the tasks of finding that card. So first, I'm going to ask you to pick a card. So a lot of you at home are probably going to pick the middle card. I just feel it. And I'm going to flip this card, and every time, like after you pick, Monty Hall would open the door without the prize. And now he'd ask you, would you like to switch? So do you want to go from the middle to the I'm pretty sure this is, for me it's rightmost in real life, but it is probably leftmost for you just because of the camera is. Anyways, would you like to switch? And let's say you said no, then you would get whatever is here, but it's a king, we wouldn't have won, but the joker is here. So, how does this work? Is there a way that, you could always kind of win, or at least come close to winning? So, I just opened Paint here, and let's just think it out. I'll put a card, like, right about now to this number file video that really explains it, I feel like, more in depth than I'm gonna. But, my goal is just to program this out into actual probability and test out the theoretical part. So here's the theoretical part. This is you, for example. Just draw a little smiley face. Okay, that's you. And let's say this is the show host, Monty Hall, for example. And he says, pick a door. Let's say you pick this door right here. You pick this hole. I'll put a big X so we know that you picked this door. And of course, Monty Hall knows which door has the prize and which doesn't. And obviously 2 out of the 3 doors do not have a prize. So he opens the door without the prize. So let's say I'll do brown. This door does not have the prize, so I'll scribble it. And he asks you to switch. So I just kind of remodeled the situation just to explain. He asks you, do you want to switch? Should you switch or not? What are the probabilities? So at first glance, a lot of you may be thinking, well, it's kind of a toss-up. It's a 50-50 chance. It could be here or here since we canceled it out. But it's actually way different than that. So I am just going to quickly go back to this part where you pick it. So right now you have a 1 in 3 chance, that the prize is behind this door, and there's a 2 in 3 chance that it's behind one of these doors. That's just a given. And when Monty decides to go show you a door without any prize, this probability just compresses. And what I mean by compresses is this probability compresses into this door, and this door has a 2/3 chance, sorry, voice crack, 2/3 chance that it has the prize. So this is how this problem works in theory. So you should, in theory, switch every time. So to test this out, I wrote some code just really quickly. I wrote some code just to test out how true is this theory. So actually quite interesting. So in this first script, I have, well, technically this is the second script. I just fired up quick scripts, quickly coded this because I cannot wait to make this video. So I printed out at the start, just so I know what script this is, run which script this is, and this script will not switch the doors. When it will select the door at the start and stick to it. So this is just a variable counting how many times we end up winning with this strategy, and we're gonna do 10,000 tests. So I first initialize a list called doors and set each of the kind of door, each element representing a door to 0, meaning there's no prize. And then I'm going to insert a prize that is random from 0 to 2. So remember, lists go, the first index is 0, then we have 1, then 2. So it's going to generate one of these three numbers, and I'm going to fill that door with the prize, and the prize is represented by a 1. And then I'm going to have a second number, maybe I should call it guess, but it's fine. And it will do the same thing, generate a random index basically. And we're going to stick to that index, and we're not even care about, the whole logic behind, this door is open or that door is open and switching and this and that. We're just going to stick to it and check, did our door that we select have the prize behind it? Okay, so I'll save this really quickly. Let me move to the next script. So same thing, I import random, just identifying, so count wins, and 10,000, turn this into 10,000. So same logic here, just putting a prize behind our random door. Okay, then we select a random door, select the initial door, select the initial. Now that I'm looking at this code, I could have done so many things that would have been so much better. You know what? I'm going to do it while doing this. Okay, so select that initial door, and what we're actually going to do is right away, I'm going to edit this code, and I'm going to just remove that door because we're going to switch. So we are just going to do doors, I believe it would be doors dot pop num2. Okay, so we're just going to get rid of it. All in all, I don't know, semicolon, or should I do del? I feel like pop is good. Okay, and then we're just gonna pop just that index. Okay, so then what I'm gonna do, I'm gonna change this code, and what I'm gonna do is for door in doors, what I'm gonna do is I could check where it is, but I don't know. I don't want to go through the hassle. So I'll do in range of just 2 instead of just 2, because I know it's 3 doors. Not the best thing to do. But what we're just going to do when doors, this is J. This won't even exist anymore. And basically over here, when I find a door with a 0, just the first door I found with a 0, I'm just gonna get rid of it, honestly. So just doors dot pop J. Yeah, straight up. Okay, and then I'm basically just gonna check if doors 0 equals 1, then I'm just going to increment count. I feel like this code is much better than before, but yeah, I hope that explained it. So basically it's just switching, just the logic behind switching. So let's just quickly go to our favorite thing. I could have ran it in VS Code, but kind of like CMD. So first of all, let's make it a bit bigger so y'all can see. Now let's do it. Let's first run main2.py. Let's see what happens. So first we need to write Python main2.py. So out of 10,000 times, we will remember, or we don't even have to remember, but it almost a third of the time. Pretty accurate to the theory so far. That was a given. That should have happened, you know, based on just like our basic intuition. Actually, no, it shouldn't have. If you think about it from the 50-50 side, that should have been actually 5,000. So this already kind of proved our point. But let's just run main.py and test it out. So you can see that your chances are pretty much doubled. Not the chances, but the amount of times you'll win are pretty much doubled. And your chances are doubled too, actually. So what did we learn from this video? Always switch. But yeah, this was an unplanned video, but I still hope you enjoyed. Kind of went longer than it had to, but I really wanted to make this right away because this concept just interests me. So wait, what's going on? Yo, someone's taking control of my keyboard. What's going on? What? CMD is telling you to subscribe to Code Talks. You guys better go do that. But please, jokes apart, drop a like, share, and feel free to comment what I should do next. And please subscribe. It would help a lot and mean a lot. Anyways, thanks guys, and catch you guys later.